Hello, everyone. Let's start this session. I'm going to present today eBPF and what's possible with eBPF. My name is Antón Rodríguez. I am a principal software engineer at New Relic. If you don't know New Relic, it's a company doing observability for other companies. So basically, our customers send to us traces, logs, metrics. We ingest them in Kafka, and then we store them in our own database so they can query that data later, dashboards and alerts and all that fancy things. How many of you are already familiar with Kafka? Can you raise your hand? Okay. For the people who is not already familiar, Kafka it's basically like a queue. It's a place where we can write very fast. And indeed, Kafka it's a writer, so it's because it's really fast writing. And then you can consume later to process the data, but the consumption is not so powerful. It's more oriented to write data. My job in New Relic is Kafka itself and all the teams and services using Kafka, so streaming. I put a lot of focus in make Kafka work for my organization. And the reason for that is because Kafka is critical, we use Kafka at a scale in New Relic, which is pretty huge. Just to give you some numbers, we ingest around 125 petabytes of data per month. And that's growing all the time. I think it's even more visual, 3 billion messages per minute. So just during this talk, we are ingesting a massive amount of messages. In the past, we have just a single Kafka cluster with 275 brokers and was super painful. Have a so huge Kafka cluster, alerts night, really painful. So like 2 years ago, we started a migration plan to move to the cloud and to, instead of having one huge Kafka cluster, have smaller servers. The thing is, in that process, we learned a lot about Kafka itself, being an observability company, about how to monitor Kafka. And this is the story I want to tell. Some months ago, my company, New Relic, acquired another company called Pixi. And this company was using something called eBPF under the hood that was totally new for me to monitor systems in a totally different way. So how many of you are already familiar with eBPF? Could you raise your hand? Okay, almost nobody. You are in the right talk. You are going to love it. And those engineers come to me and say, hey, Anton, you are doing a lot of things with Kafka. And we are starting to monitor Kafka using eBPF, right? And the thing is, could you tell us about challenges you have or things you are not solved monitoring Kafka so we can try to solve those things with eBPF? When I had that conversation, I said, yes, okay, let's do it, why not? But being truly honest with you, I think you are going to waste your time. You are not going to be able to monitor Kafka even using something magical as eBPF and provide that information. It's impossible. And the thing is, I was wrong, totally wrong. They did it. So I'm here today to tell you how they did it and how cool is this new thing, eBPF, and the things you may think are impossible for you with other things, not necessarily with Kafka, which maybe you can monitor now with eBPF. That's the goal of my talk. So, what is eBPF, right? Well, eBPF is a new kernel feature. And if you think in other disruptive technologies as Docker and containers, they also started with new kernel features, right? eBPF, basically what allows us is to tell to the Linux kernel, hey, when something happens, like a program opens a new connection, or a program opens a file, or there is an invocation to a system library, generate an event, and notify me, my service, about that event. So you can know what's happening internally in Linux very, very easily. And has two things which make it very, very different. One is it's the low overhead. Configure eBPF or create eBPF programs to monitor things in the kernel. The overhead it's really low. The CPU consumption is really low compared with other ways. Why? Because eBPF program is compiled to bytecode, something similar to Java, even if it's not Java at all, and it's sent to a virtual machine inside the Linux kernel. So we have all those things performance related, like just-in-time compilation and all those optimizations, which makes sure eBPF is going to run in a very performant way. The second thing which is very interesting in eBPF is safety. The Linux kernel is a critical piece of the stack of our applications, so we don't want to break things there, right? We don't want to create any problem in the Linux kernel. And the thing is, with eBPF, we are going to have this program running in the virtual machine. When an event happens, eBPF is going to invoke that program to execute it and to make an operation or to send that information to our application, so we can send it to New Relic or to any other place to take any action. But the thing is, this program running in the virtual machine is going to be validated. So it has a lot of safeguards and a lot of limitations to make sure that program, whatever it does, is not going to break things internally in the kernel. So that makes a lot easier to develop programs and also to upgrade them later, to deploy in different operative systems, makes the whole thing much more easier for all the developers out there. So eBPF, new Linux capability, two main benefits compared with other alternatives, low overhead and safety. Now, okay, how we can start using eBPF to monitor things? The first thing is something called BCC. BCC is a toolkit. It's developed in C, so you need to know C. It's quite easy with this if you know C and eBPF and the Linux, how to work with the Linux kernel. You can create command line programs or more complex things. That's to give you some examples. Sorry, it's a bit blurry, the screen, but I'm going to explain them. You can create, for example, a program to measure the disk I/O latency of your services. So this is very interesting for Kafka. It's a typical pain we have when operating with Kafka, and the disk is very slow, and that's generating problems. Or you can create another one to tell you new processes launching the operative systems, or each time a new TCP connection is open, or any other custom tracing. So with BCC, if you develop in C, you can create all those programs. Oh, thank you. It's much better now, right? Thank you. Now, there is a couple of wrappers in top of BCC, so you can also do some things in Python and Lua. But even with that, it's quite hard for someone who is not hacking in the kernel to use eBPF. And that's the reason for bpftrace. bpftrace is another command line, and basically it's a domain-specific language. That means you don't need to learn all about eBPF, just the specific parameters of this domain-specific language, and with that, you can start developing your own applications. And it's super powerful. You can see here with just one line, you can do things like identify the files opened by a process, or how many syscall is doing a program, or how many bytes are reading a process, and so on and so forth. So there is, just with one line in bpftrace, we can do a lot of things, and we can, of course, build more complex programs. Now, another benefit of Pixi, about eBPF is you can easily use it with Kubernetes, most of the time running on top of Linux. And indeed, there is the kubectl trace, which is using bpftrace under the hood. And the idea of this is I want to see how files opened by a specific service deployed in Kubernetes you can create this one-liner, and with the kubectl trace, you can deploy it and have access to that information. So even with Kubernetes, you can use eBPF under the hood and take advantage of the Kubernetes standardization layer to obtain all that information. So eBPF and Kubernetes works very well together. Now, this is nice. It's an improvement. It's easier to use than BCC, but we are still in the command line. It's yet hard to operate all those files. So let's see next example. The next example is eBPF exporter. This is a project open source by Cloudflare, and the idea here is to use VCC to have like some scrappers using eBPF and sending that information to Prometheus, and from Prometheus to Grafana. So with that, you have all those metrics. You now have Grafana. You can have your own dashboards, have some advanced functionality, but the rest still have some limitations. If you want to add new metrics or you want to monitor a system which is not supported, you still need a lot of knowledge in order to be able to do that. Okay, so it's a pretty cool project, but and can solve a lot of problems, but it still requires a lot of expertise and experience working with those things. So this is where I introduce Pixi, the product those engineers are working on. So Pixi, first of all, it's totally open source. It's part of the Cloud Native Foundation. It's not from any specific vendor, so it's totally open source. I'm not here to sell anything to you. You can use that. You don't have to pay anyone, and because it's part of the foundation, it's going to be open source forever. So that's, I think, in my opinion, super cool. It's using eBPF under the hood, and the thing is, it's something you deploy in Kubernetes as an operator, so you don't have to modify the code of your applications or your deployments or anything like that. It's just you type a command, you deploy it in Kubernetes, and it is going to start to monitor your Kubernetes cluster and all the services on it. And one of the things interesting is it's able to detect if you are running things like Kafka or a web server or MySQL or Postgres or many other things. It's going to be able to detect that and to generate insights or specific metrics for those applications. So today, what we are going to see is how Pixi is able to detect Kafka and generate metrics specifically for Kafka. But it does the same thing for other databases and servers, frameworks, and so on. The list is quite big at the moment, and it's pretty easy to add new ones if you don't have something you are using. Now, how it works. What we do with Pixi is we deploy Pixi in Kubernetes. In every node of our Kubernetes cluster is going to deploy a PEM, what we call a Pixi Edge module, which is under the hood going to subscribe using eBPF to every pod, every service deployed in Kubernetes, and is going to extract that information and store it internally in every Kubernetes cluster. And then using the UI, we can query that information and create dashboards, create alerts, and do whatever we want, or even exporting it to other places. So this is how it works under the hood. The information is stored internally in Kubernetes. So in your service, you don't need to export if you don't want the information to a third party, which from the point of view of security could be interesting. It's working using all the Kubernetes standardization. Now, one of the interesting things in Pixi is it's able to detect all the traffic between applications and servers. So in this case, one of the things Pixi is doing is I'm going to subscribe to all the messages, to all the packets which are being sent to Kafka, to a Kafka broker, to a Kafka node. So that Kafka broker running in the JVM is going to access under the hood the Linux API, and Pixi is going to subscribe to an event in the middle of that. You can think in something similar to Wireshark, where you are sniffing the traffic. It's pretty similar to that, but it's working in an upper level. It's not working so close to the network interface. What it's going to do Pixi here is I'm going to subscribe to all those network messages. I'm going to filter the Kafka messages, the Kafka protocol messages. So when we are using Kafka, Kafka uses an internal protocol for interchange metadata between the brokers and the clients. So it's not going to read the payload or the other messages you send to Kafka, only this control protocol, and is going to deserialize them, or parsing them, understand what's happening, and with that information generate specific metrics. We are going to see that with a live demo, which is more easier. But first, let me introduce the first problem. So those engineers ask me, what are your problems? And my first problem was the setup to monitor Kafka. Because Kafka, it's quite complex, and to understand what's happening with Kafka, you need to do a lot of things. You normally need to have metrics in the hardware level or operating system level. You need to know what's happening in the Java virtual machine. You need also all the specific Kafka metrics, and those are exported to using something called GMX. So typically, most of the people deploy something called GMX exporter, which is a jar you put in the class path. And this jar is going to take those metrics and make them available for something like typically Prometheus, to have those metrics then available in something like New Relic or Grafana or whatever you use to have access to that. So all this setup is not easy, requires some time, some automation. In the case of GMX exporter, at least what we see in production, the performance hit is quite high. It's easily 10% of CPU, and indeed we migrate from the GMX exporter to a Java agent because it's much more efficient for us. So all these things, it's challenging to maintain all that. So my first challenge is, could you help me to monitor Kafka without having to do all those things? And that's what we did, what they did. So demo time. Sorry, and I don't think you are able to read the comments at all, but let me explain you. This is the setup of the demo. What I did was, first of all, I created a Kubernetes cluster in Google Cloud. I choose Google Cloud because they give me free credits, and that's nice. But you can use AWS or Azure or where you want. So first of all, I created a cluster. The second thing is I deployed Pixi in that cluster. So you don't see it, but basically it's px deploy, and that's all I have to do. Px deploy is going to deploy Pixi in the cluster. It's an operator, is going to send all those metrics. After that, what I did was create an namespace in Kubernetes for Kafka and deploy a Kafka operator called Streamsy. Streamsy is an open source project, also part of the Cloud Native Foundation, and the idea is make easy to deploy Kafka in top of Kubernetes. So basically, you do a create kubectl create the operator, and then another command kubectl apply to create the Kafka cluster in Kubernetes, and that's all. And with that, if it works over public Wi-Fi, we should have Kubernetes with Pixi and a Kafka cluster deploy. So now let me introduce Pixi. Once we have Pixi deployed, it's going to start sending metrics. So we can go to work.withpixi.ii and see our metrics here, or you can also host your own UI. Pixi Here we can define the cluster we can see. We can have different scripts. So different scripts allow us to see different things. In this case, Pixi cluster, it's an overview of the Kubernetes cluster. And we want to see the metrics for the last 5 minutes. Okay? And clicking on Run button, we can execute the script. That means we update the metrics for the last 5 minutes. So things we have in Pixi out of the box without do anything, just because I deployed it just before the talk. The first thing is it's able to deploy to identify all the services we have. Sorry about the blurry screen. I promise you it's much better in my screen. But here you can see all the pods we have deployed in Kubernetes. Basically what I'm doing here, Pixi, is seeing how they connect through HTTP. So it's tracing all those messages, and I'm saying between those two pods, there are 1 kilobyte/second of messages with this latency, and you can discover all the services deployed in your Kubernetes cluster. Now, oh, this was the browse bot. Okay. Now, I'm not used to use so high resolution for the demo. Now, more things we have with Pixi is going to identify. Okay, you are running 2 Kubernetes nodes. Sorry, the CPU and the number of pods we have in every node, so we know how much load we have in Kubernetes. It's able to identify all the namespaces, so we have 5 different namespaces with so many pods and accounts. It's able to identify all the services and give us some numbers about the latency. Again, all the pods we have with the CPU, how much they are reading from disk or writing to disk, how many containers they have. One interesting thing is we can go to any of these. Let me choose something. For example, the Pixi. And we can see a specific information for every pod. So in this case, this pod is not using HTTP at all, but we can see the CPU, we can see the container list in case you have more than one, the processes even inside the container. We can see how much traffic it's sending and receiving, the memory in case there is any type of problem, more HTTP, which we are not using. We have even flame graph for all the pods we have. I think this is pretty cool. So if you are having problems in one of the applications deployed in Kubernetes, and you see it's consuming a lot of CPU, you can go to Pixi and it's able to generate this flame graph for you in real time and see in what parts of the code you are spending more time. So if you have a bottleneck there, it's pretty easy to identify it with Pixi, at least with a less blurry screen. Okay. Now, so this was the first challenge I have for them, right? And they did it. Deploy Pixi, it's super easy if you are running Kafka and Kubernetes. My second challenge was, or is, identify clients. And the thing is, in New Relic at the moment, we have hundreds of clusters and thousands of different clients, some of them using different technologies, most of them in Java, but there are some of them in Go, some of them in Kotlin, things using Python because they are data science and they have to use Python. It's mandatory for them. So it's not easy for me as someone working more in the cluster side of things, in the server side of things, to know who is using Kafka and for what. You know, sometimes I have to tell them, hey, why you are using this so old version of Java, of that so old version of this Java library. And for me, identify them, it's not an easy task. So that's what first I told them. It's help me to identify all the producers, all the consumers, and all the topics. So it's like the tables in a database. It's a unit logic of information. Let me to see how they are related and what they are doing in general. And this is what they did. So if we go to the beginning of the web page, and I choose a script called Kafka overview, they created this thing, which is, there is nothing here at the moment. So let me launch a Kafka client. We're going to launch here, it's a producer, which in a couple of seconds, if the Wi-Fi works well, should start sending data to my Kafka cluster. Okay, here we go. And now I'm going to launch a consumer, which should be reading data from my Kafka cluster. Also, okay, here we go. It seems like it's working. Now we run a game, and here we go. We are sending data, and Pixi has been able to identify there is one producer sending data to a topic called Pixi, not very original, right? And reading, we have a consumer task 1, which is an application consuming. And if we click on the arrow, okay, it's even able to give us how many messages and how many kilobytes or kilobytes per second that producer is sending. Of course, this is a hello world example, just one producer, one consumer, one topic. But if you have a very complex topology with many topics, many consumers, many producers, it's able to connect all of them, right? Also for the consumer, we have data. So now Pixi, again, without changing anything in Kafka or using the Kafka metrics, it's able to detect there is a Kafka topic called Pixi with 2 partitions, 1 producer, 1 consumer, and this traffic. We have a Kafka broker path. So this is my Kafka cluster has just only 1 broker, only 1 node, which is receiving this traffic and doing those things. So we can know here how busy, how hot we are running our brokers. We are also able to identify all our producers and our consumers, right? And finally, from the perspective of the pods, we can see also how they are related. So we have a pod, my cluster Kafka 0, and those pods, Kafka consumer 1, Kafka consumer, Kafka producer per 3 are producing from them. So this is exactly the information I wanted to have, and specifically this one, how Kafka, how they are working together, right? Okay, now let's go with the next challenge. For me, the next challenge was Kafka consumer lag. How many of you are familiar with consumer lag as metric? Could you raise your hand? Okay, not too many. Okay, consumer lag is probably the most important metric when working with Kafka. This information, what it's going to tell us is how many messages are in Kafka not being consumed. From an ideal point of view, what we want to do is our consumers read messages from Kafka as soon as possible, because that means less latency, and that means the metrics and the information our customers send to us is going to appear in the database sooner, right? So we don't want data waiting in Kafka. We want the data to be processed as soon as possible. So if we see the data, it's being stored in Kafka for a lot of time or not being consumed, and that means there are problems. Okay, and that's why consumer lag is so important for us, is because it's what we typically are looking to identify if we have any type of problem. Maybe the producers are sending too much data, or maybe we have some bottlenecks in our Kafka clusters which are not identified, or maybe our consumers are having problems, like they are rebooting all the time or things like that, and they are not able to consume as fast as they should. So consumer lag, it's a very, very important metric. Normally, it's measured in offsets, and that's the position in Kafka, or we can think of it as the number of remaining messages. The thing is, to have consumer lag, most of the time from the server's perspective, it's not provided out of the box by Kafka. Most of the people out there have to use some external service to have consumer lag. LinkedIn from Barrow from LinkedIn, it's very popular. Also the Kafka lag exporter for Livent, it's very popular, both of them open source. And one of the interesting things of the Kafka lag exporter is it's able to give consumer lag not only in the number of messages, but in seconds. And this is very useful for us, because if someone tells me, hey, Antón, we have 50 messages remaining to be consumed in Kafka, I don't know if that's a problem. 50 messages, that's a lot, that's not a lot. But if someone tells me, Antón, you have a consumer lag of 30 minutes, I know that's a problem. That means there is 30 minutes of delay in our metrics. It also means at some point we could lose data, because we typically store data in Kafka for a specific period of time. So with consumer lag in seconds, it's much more useful. But even after years working on this, it's still a hard metric to obtain, because you need to do a lot of interpolation and understand how the consumers are behaving in order to be able to calculate this metric. So what I told those engineers is, could you generate this metric consumer lag in an easier way? And that's what they did. So let me show to you. So basically, they create a new script, Kafka consumer producer consumer latency. I'm going to choose here the Kafka. And at the moment there is nothing here, right? So what I'm going to do is I'm going to stop my consumer. It's going to stop consuming, and that should generate consumer lag, because now I have the messages waiting in Kafka. I'm going to launch it again. And here, if we select the topic Pixi, now you can see we have the topic Pixi, one producer, one consumer, and this is the information I want to have. Just 1 second before, the consumer lag for both partitions, we have a spike there because we stop the consumer and the number of messages start to accumulate inside Kafka. Okay, then if I run again, I restarted my consumer and the consumer lag went to 0 because it was starting to read all the messages really fast. Okay. So now we have that information. We can see per partition how is the consumer lag. And typically our engineers will have an alert here. If consumer lag is bigger than 300 seconds, generate an alert, open an incident, and work in what's happening, right? Now, how these Pixi engineers were able to obtain this information, because Burrow and the Livent exporter, they go internally in Kafka to extract that information, but they were able to measure this without anything like that. And I'm not going to go into the code here, but I'm going to show you something which is Kafka data. So Kafka data are all the messages in the Kafka protocol between the broker and the applications. So if you're familiar with the Kafka protocol, there are things like fetch, which is Kafka, give me data, or produce, which is Kafka, I send the data to you. Things like heartbeat, which is Kafka, I am alive, continue, let me consume data, or offset commit, which is basically telling Kafka, I finish consuming data in this point. Okay, so all those messages from the Kafka protocol are being parsed and are available in this screen. If we click in any of them, we can even have access to the value of them. I'm not with the screen, I'm not going even to try, but you have all the information sent between the Kafka broker and the clients. So for them to measure consumer lag, again, error. Okay. So for the consumer lag, what they are doing is they are tracking the produced messages, and they have a specific ID every batch of messages, and the fetch messages, which also have an track ID. What they're doing here is they are doing the difference between the produce and the fetch, and if the fetch is growing, there are more and more difference. That means consumer lag is growing because it's taking more time to read those messages. So for us, and for people working with Kafka, was super interesting how, from the external point of view, they are measuring this information, accessing the internal messages. One thing is, I'm not going to show you too much here, but if you click here in the editor, you have access to the code to generate this dashboard. This is kind of similar to Python, but with some specific limitations because of those safeguards we were speaking in eBPF. So things like a loop, it's something you cannot do in eBPF because you could do infinite loop, and that will break the Linux kernel. But in general, it's pretty easy. And the thing is, here in Pixi, you can change the script directly here in the UI. You can share it later. You can create your own scripts and do whatever you want. So it's super useful. If you have other use cases for Kafka or any other software, you can see here we have a lot of other scripts, GVM, MySQL, etc. You can just take a look to the script, see how they are doing it, and modify the script for your use case. So this is the second challenge. Running out of time, so let me go with the third one. Third one, and this is super painful for many teams using Kafka, is what we call rebalances. Kafka internally works with the concept of partitions, and this is where we send the data. Partitions are the unit of parallelisms in Kafka. So when an application it's reading from Kafka, it's typically reading from one partition, and there is an assignation between that consumer instance, or that instance of our application, and the partition. By default, we cannot have more than one consumer instance reading from one specific partition, right? The thing is that negotiation to decide what partitions go to what consumer instances is done in real time between the Kafka cluster and the consumer instances. If we add a new consumer instance, in this case consumer instance 3, the cluster and the consumers need to renegotiate again to decide what partitions go to what consumer instances. During that negotiation, Kafka, the consumers stop consuming because they cannot consume and renegotiate at the same time. So they stop consuming, they decide, okay, partition 0 goes to consumer instance 1, partition 1 goes to consumer instance 2, partition 2 goes to consumer instance 3. Now we all agree on that, and now we start consuming again. The thing is, this process is can be very painful because that is going to generate consumer lag in the pipeline. So that happens from time to time, and it's sometimes very hard to know why the rebalancers are taking so long. And think this is a very easy example, but thinking applications with 500 instances, 500 partitions, all that negotiation can be quite costly. So my challenge for them was help me to help the teams consuming from Kafka, giving them more information when rebalancing is happening, to identify those things and to have better insight about what's happening. And this is what they did. So back to Pixi, they create a new script called Kafka consumer rebalancing. So what I'm going to do now is launch a new consumer. So consumer 2. Here, if we run this and we filter by, I don't know, I don't remember the name. Here we go. So now we have a group of consumer called test, which have 2 consumer groups in this moment. And as you can see, there we have a consumer rebalance. So we have consumer rebalance, one member, consumer test 1, and the hash of the container, which stop consuming from 1.4 seconds, and the other one which stop consuming from during 4.4 milliseconds. The reason is because the new one usually takes longer to start consuming. So this is giving us all the information about, one consumer, one rebalance happened, affecting this consumer group, and it took this time. So this is super useful information for the teams to understand how many consumer instances were involved in a particular rebalance. And even here, we can see all the messages in the Kafka protocol, which are sent between the consumers and the producers, the consumers and the brokers to do all that negotiation, okay? So if you are interested in how this works under the hood, you can even go here and take a look to those specific messages. I did a talk in the Kafka Summit going into detail on this. If you are interested, it's recorded. So I think that's all I have. There are no more challenges at the moment for them, but they are looking for new challenges. So if you have any ideas, let me know, or I'm happy to put you in contact with them, or just take a look and see what you can do by yourselves. Summary. Kafka, it's a pretty challenging system, a distributed system for observability. eBPF, it's something pretty new yet, but it's really disruptive in monitoring, in security, in networking. Those things, the use cases you can do, the things you can do with eBPF are really awesome. The community is very active. It's growing all the time with new things. So if you are interested in any of those, take a look to eBPF. Finally, Pixi, open source project in top of eBPF, which allows you to monitor Kubernetes applications, doesn't require modify your code, redeploy your code, super easy to use, is going to understand some of your services, and the overhead in general is quite low in comparison with other alternatives. With that, I think it's all for this talk. I would love to have your questions, answer them now or later in the whole if you prefer. Thank you. Questions?
How does this work when you add TLS to the mix?
Yeah, question. TLS is kind of tricky. So if you are using TLS, the messages are going to be encrypted. So most of the metrics are going to work anyway, like CPU and so on. But when you want to parse the protocol or the HTTP messages, it's going to be a bit more challenging. I'm not aware of the details. Being honest, I'm not a Pixi engineer, but what they told me they're doing is they are subscribing to events when applications are calling the internal libraries to retrieve the certificates and all that stuff. So they have access to the certificate doing that, and then they use the certificate to decrypt the messages. So it seems like, you know, pretty, I don't know if cool or scary or what, but it seems like it's working. And it's also a good example of how powerful this is. More questions?
Hi. Could you use this solution with other message brokers like RabbitMQ, or is this just tuned up for Kafka?
I think there are other integrations, other scripts for things like RabbitMQ. I never use them. I only work with Kafka. So I don't know how they are compared to Kafka. But for sure, it's perfectly possible to have something similar for RabbitMQ. But I don't know it's exactly the status at the moment. But the easier thing is to ping them in Twitter or ping me. They will tell you exactly what they are. And probably also, if you are interested in specific metrics or have any idea in mind, they can help you to create those initial scripts.
Does this work for things outside of Kubernetes? So, for example, if I have Kafka cluster outside of my Kubernetes?
Yeah, that's a good question too. Pixi only works for Kubernetes at the moment. So it can work with Kubernetes on-prem or in different clouds, but you need Kubernetes. The thing is, because it uses Kubernetes to discover the services, so it lists all the pods and detects what type of service you're running on it. So if you want to use Pixi, you need. If you want to use eBPF, things like the eBPF exporter or some of the tools, you don't need Kubernetes, and you can do that at your own, but you don't have some of these easy-to-use features Pixi provides. I don't know if they have in the roadmap to have something with Pixi in the future out of Kubernetes. It seems like quite complicated.
Runtime security. Oh, thank you. The Pixi team's been playing with runtime security, being able to see sort of like CPU abnormal usage. Is that going to be available straight up in that sort of dashboard?
If I understand the question, it's about security features in Pixi, the roadmap for them. Yeah. I know they are working on things like that. Again, I'm a user, not a Pixi engineer. I know they were doing things like identify log4shell and being able to list it in the roadmap. So probably they're doing things in that space. And I think they're going to do more and more. Yeah. But I'm not aware of anything specific coming. But again, I may be missing things on that because I'm really more a user and more focused in the Kafka thing than in security. But I'm happy to put you in contact with Amit or Ryan, and they can give you all the details.
Yeah, I'll hit them up in their issues and PRs again. It's so cool. Yeah, awesome. Thank you.
Thank you.
So, related to the question about being only possible to use it with Kubernetes, do the consumer and producer applications also need to be running on Kubernetes, or is there some kind of eBPF exporter that we can, for Pixi, to run on applications where the broker is running on Kubernetes, but the actual consumer and producers are not?
Yeah, good question. The thing is, Pixi at the moment, it's listening in the broker side. So even if your applications are not in Kubernetes, you are going to have access to that, a lot of information. Things like the rebalances, you are going to have access to that information. But you are going to lose some other things, like sometimes you click in the consumer and you can see that frame graph, some specific metrics which are coming directly from the consumer. You are not going to have those ones. But the general overview of what's happening at the Kafka level, that's something you are still going to have because it's listening in the broker side, not in the consumer application side.
So not possible to have all those metrics still with some kind of plugin for the producer and consumers?
What you can do is export the metrics directly from the consumer producer and the metrics from Pixi to the same place, like New Relic, for example, and then you can join those metrics together. But other than that,
not Pixi on a custom.
Yeah, not Pixi. I'm not aware of if you can add external metrics to Pixi. Maybe there is some workaround out there, like have a specific script and then. But if it exists, I don't know it at the moment.
Okay, thanks.
Okay. If there are no more questions, thank you very much. I'm still here in the conference. Feel free to say hello if you have more interest on this. Thank you.